Hello dear, today we'll see what are the uses of spherical mirrors. Okay, uses of spherical mirrors. We have two spherical mirrors in common use, that is your concave mirror and convex mirror. First we'll see the uses of concave mirror. Okay, so this concave mirror is used to focus a beam of light at a point, and it is used to get a parallel beam of light, and also used for the used as a magnifying mirror. Okay, for these purposes we'll be using the concave mirror. So first we'll see how to focus a beam of light at a point. Okay, not only light, it can focus not only light, the waves also, this like electromagnetic waves and all. Okay, first we'll see it is to focus a beam at a point. This is common one, dish antenna, right? You can see your dish antenna in your terrace, right? So it will be like this. It is like a concave mirror, curved inwards. This is your non-reflecting sides. So your antenna will be fixed like this, right? You remember that it is fixed in the parapet wall of the terrace, right? So you will be having a receptor at this point, some receptor, receiver, or you can say receptor at this point, focused at the center. Okay, so you will be getting the signals from the satellite. It is satellite means it is from infinity, right? So the parallel rays will the rays will come parallel to the principal axis. So this is your principal axis, and the rays will strike parallel, right? Because it is coming from infinity, it will be parallel to the principal axis, right? It is parallel to the principal axis. If the rays are coming from infinity, where it will image will be formed at the focus, you know that, right? So all the light will incident, which is parallel to the principal axis, will reflected back like this, right? Through this point, through this focal point. Okay, so your electromagnetic waves will strike this concave mirror, and it will be reflected back, and you will get the full frequency at this point, radiation at this point. So here the receiver or receptor is kept. You will get the frequency, and you will get whatever channel you want, right? You can watch it on the TV, right? This is the purpose of concave mirror. It is used in the dish antenna. Okay, likewise in doctor's head mirror, the ENT doctors used to have some head mirrors, right? You remember this will be their band, and it will be fixed with that. We will have a mirror like this. At the center a hole will be present. Okay, this is a doctor's head mirror. How they will use, patient will be sitting here. Okay, adjacent to the patient they will keep the light source. Okay, doctor will be here. This is your patient, this is your doctor. He will wear this headband with the mirror. Okay, so here the light source is kept adjacent to the patient, so he will receive the light, and it will be focused at the focal point. Okay, he will be sitting nearer to the patient only, right? So at the focus point, this he will adjust himself so that this focus point will fall on the face or nose or ears of the patient. Okay, clear on this, so that he can view clearly. So doctor's head mirror, that is we are going to focus all the beams of light at a point. Okay, next, same concept works on the solar furnace also. You will be having a concave furnace, concave shape. So the sunlight is from infinity, right? So this is a principal axis. Sun rays will hit here, solar energy. It is parallel to the principal axis, so it will focus at a point, at the focal point. All will be concentrated here. So you will get the heat here. So you can keep the things here, and you can heat anything. Okay, so this is working of the solar furnace. So the aim of this three thing is to focus the light source or heat energy or electromagnetic radiation at a point. Okay, when it happens, when the light are parallel to the principal axis or waves are parallel to the principal axis, then it will be focused at a focal point. Okay, so these are the three uses. It is used in dish antenna, doctor's head mirror, and also solar furnace. Okay, next, to obtain the parallel beam of light. Okay, for how, what is the purpose of torch? We will point something and we will search for something, right? We will point at anything, and you will, if you see your torchlight, if you switch on that, you will get a parallel beam of light, right? When you will get the parallel beam of light? When the source is, the light source is kept on the focus point. You know that when this source is kept on the focus point, it will strike it, this rays will be parallel to the principal axis, parallel to the principal when it falls parallel to the principal axis, it will reflect it through the focal point, right? So when it is at the focal point, it will be parallel to that and reflected back through the focal point. When it is passed through this focus point, and something is, so for example, if your light source is kept at the focus point, then it will pass through the focus, mean then it will be reflected back parallel to the principal axis, right? So if you keep the your torchlight will be like this, somewhat like this, right? This bulb is kept at the focus point. It will strike the mirror and it will be reflected back like this. It will strike the mirror, it will be reflected back like this, and you will get a parallel beam of light, right? It will strike the concave mirror, and because it is the light is focused from the light is passed through the focus point. Focus means when it passed through the focus means then it will be reflected back parallel to the principal axis. So you will get a series of parallel beam. This is how the torchlight works. You can imagine that, right? It will be like this. You will get a parallel beam of lights. This is how your torchlight works. Because this bulb is kept at the focus point, it will strike the mirror and rays will be reflected back parallel to the principal axis. Okay, clear on this? Same way the searchlight also, and also in the vehicle's headlight also. If you see this car, the headlight will be, you can see the rays like this, right? When you are traveling at the night, you can able to see that, right? The rays you will get a parallel beam of light. Same principle. Your light source is present at the focus point, so that it will strike the mirror and reflect it back parallel to the principal axis, so that you will be getting a parallel beam of light. Okay, your light will not be focused like this, right? But you can see the light downwards also. How you can see the light downward also means, here in the vehicle you will be having a mirror to deflect the lights. Okay, here some arrangements are there to deflect the light, so that the parallel beam of rays will fall here in the downward direction also, so that you can able to see the ground. Okay, so to get the parallel beam of light, this concave mirror is used. Okay, next, for magnifying purpose means for doing the makeup work, or if you went to the dentist means, you can able to see that you'll be having a long steel like structure fitted with the mirror here, small mirror. So you used to keep your teeth will be like this arrangement. He will keep the mirror over here, and he'll see the enlarged size of the teeth at the mirror, right? When will you get this enlarged erect virtual image? You will get this enlarged erect and virtual image when the object is placed between the pole and the focal point. Okay, so he will keep near to the teeth. So this teeth will be present in between the focal point of the mirror and the pole of the mirror. So somewhere here means you will get the image. Where will you get the image? Do you remember this concept? This is passes through this. When it passes through this, and one more thing is pass through the center of curvature. It will be like this and it will go like this. It never meets. So it appears to converge. It appears to converge at a point. That point you will get a enlarged virtual erect image. Okay, to get the magnified image of something, we use the concave mirror. Okay, to get the enlarged erect image, the object has to be placed between the focal point and the pole. Okay, you used to keep the makeup mirror nearer to you, right? So it will be like this. You will get an enlarged image so that it is easy for you to do the makeup work and also for shaving purposes. So if you get the enlarged image, it is easy for you to correct that, right? And also for dentist to see the enlarged picture of this teeth, he will do this routing, and if any cavities are present, he can clear that one, right? So to get a erect and enlarged virtual image, we use the concave mirror. So what are the three uses of concave mirror? To focus the beam of light or waves at a point, to get a parallel beam of light, and also get a magnified enlarged image, right? So in case of focusing of the beam, we used in dish antenna, doctor's head mirror, and solar furnace. To obtain a parallel beam, this concept is used in torch, searchlight, and vehicle's headlight. And magnifying mirror, to get an enlarged image, we use in the shaving mirror, makeup mirror, and dentist mirror. Okay. Next we'll move to the uses of convex mirror. Convex mirror, it is used in the rear view mirrors in vehicles. In the vehicles, you have two wings like mirror, right? To see the traffic behind your vehicle, we use this rear mirror. Okay, why? And in shops, you can see at the corner of the place, they can keep the convex mirror, right? They keep the convex mirrors. It is curved outwards. Okay, why it has been used means you can have a wider field of view. So to get a wider view, so it cover the whole. You can see that it can cover the whole shop like this. Okay, you can see everything at this mirror. Okay, that is used for anti-theft. All right. So it covers a whole area, so nobody can steal anything. Okay. Why do we prefer a convex mirror as a rear view mirror in the vehicles? So commonly asked question. Okay, because it gives a wider field of view. Okay, you know that how will you get the images, where the images will be formed in the convex mirror? You know that here always it may be your source of light, or your objects will be placed somewhere between the infinity and the pole, right? Infinity and the pole, you will get the image at the between the you will get the image, diminished image, virtual erect image, right? It will be between the pole and the focal point, you know that, right? So you can get the full image of the object in a diminished size, and it covers a wider range. Okay, because it gives a wider field of view, because you will get a diverging light. Whenever it strikes, it will diverge like this, right? Whenever it strikes, it will diverge like this. It will be diverging like this, because it from infinity or between infinity and the pole, you will get the diverging effect. So because it gives a wider field of view, thus it helps the driver to see most of the traffic. So it covers a large part so that he can see what are all coming behind him. Okay, most of the traffic behind him, or to facilitate the safe driving. Clear? So why do we prefer convex mirror over a plane mirror in a vehicle? For this purpose, we can use the plane mirror also, right? But you know that how the image will be formed in the plane mirror. It will give the exact size of the object, right? How the image will be formed? Equal to the size of the object, right? So it will cover only few parts of the vehicles. For example, it will cover the headlight of the vehicle, means only headlight of the vehicle will be viewed in the rear mirror. You don't know whether it is a car mirror or a truck mirror or even bike. You don't know, right? So unless you get the full image of the object, you will not find which vehicle is coming behind you, right? So why do we prefer convex mirror over a plane mirror? Because convex mirror gives erect diminished image. Okay, erect diminished image, whereas a plane mirror gives the size of the image as same as the size of the object. So you will not predict what vehicle is coming. So when the convex mirror, it makes the image to a diminished size, so that you will get a full image of the object, whether car is coming or truck is coming, or bike is coming. You can guess like that. Okay, you can see. And also this convex mirror give wider field of view, whereas the plane mirror gives narrow field of view. Plane mirror you will get only narrow field of view, whereas in the convex mirror you will get a wider view. You can get like this. Okay, here only narrow things. Okay. And also next question, why do we prefer convex mirror over a concave in the vehicle? Okay, in the same thing only. In the convex mirrors, it give erect diminished images, right? It always give erect and diminished image wherever when the object is at infinity or between infinity and the pole, right? But in case of concave mirror, you can give both erect, inverted, enlarged image, right? Because you know that this is your concave mirror. If this vehicle is behind this center of curvature, you will get the image real and inverted. You will get the inverted image between C and F. Okay, when the vehicle is nearer to this center of, or in the center of curvature, you will get the image in real and inverted image with the same size. If it is at the focus point, you will get again the enlarged image. When it is between the focus and the pole, you will get a real virtual image which is enlarged. So depending upon the distance between your vehicle and the vehicle behind you, you will get the alternatively inverted, real, enlarged, small, like this you will be getting. So it will not give a correct picture of what is actually coming and what about the traffic behind you. So only if you fix the convex mirror, you will get always the erect diminished image. If you fix the concave mirror, when the vehicle is very nearer to you, you know that when the object is placed between the focal point and the pole, you will get a erect image, erect enlarged image. When it is far away from you, you will get a real and inverted image. Okay, so you will get confused. So this concave mirror is not preferred. Okay, so you will prefer only the convex mirror for the vehicles. Clear? Thank you.